Good morning, everyone. I hope that everyone is staying warm because it is very cold outside right now. Today we're going to be going over 6.6 common fractions, adding mixed numbers with unrelated denominators. Now, in 6.4, we talked about related and unrelated denominators. When we have unrelated denominators, okay, that means we're going to be changing both fractions. Changing both fractions that we're adding together, because unrelated means that 3 doesn't go into 4 evenly or 4 doesn't go into 3 evenly. So we're gonna have to change both of them so that we can add them together. So let's get started. So how would you calculate the total amount of juice and water in this apple cake recipe? So let's look at our recipe. We've got 1 2/3 cups of apple juice and 1 1/4 cups of water. So those are the two that we're going to be adding. And then it has 1 1/3 cups of oats and 1 1/2 cups of flour, but we don't really need to know that. We just need to focus on these two. We're going to be adding these two together. So Hugo changed the amounts to improper fractions to add. Charlotte used mixed numbers. So Charlotte broke these down and added them that way. And then he changed both of the mixed numbers into improper fractions. So we've done this before, but we're going to go ahead and go over it just the same. So we've got 5/3 and 5/4. And since they're unrelated, since one can't go into the other evenly, we're going to change both of them. So let's do 5/3 first. Okay. So, and remember, when we have unrelated, we're just going to multiply them together. 3 times 4 is 12. So our denominator is going to be 12. 3 times 4 is 12. 5 times 4 is 20. And then we have 5/4, which we want them to be 12 because our denominator is going to end up being 12. So 4 times 3 is 12. 5 times 3 is 15. So our new fractions we're going to be, improper fractions we're going to be adding are 5/3 or 20/12 plus 5/4, which is 15/12, which equals 35/12. Okay, so 35/12. Now with Charlotte, she just broke these down. So she decided to break them by doing 1 plus 1 plus 2/3 plus 1/4. We're adding the wholes and the fractions. So we're still gonna have to change these fractions. We can't add them together to get 7. We have to change them to 12 because we're using the same denominators, remember there. All right, so we need to change 2/3 into the 12, and we need to change 1/4 into 12ths. So 3 times 4 is 12. 2 times 4 is 8. 4 times 3 is 12. 1 times 3 is 3. So 8 plus 3 is going to end up being 11/12. All right, so now our whole numbers are 2 and 11/12. All right, so what will Hugo and Charlotte need to do before they add? Well, we changed both fractions because they're unrelated denominators. How should Hugo rewrite the fractions to add? What steps will he follow to calculate the total? So we changed the denominator, and then once we changed the denominator, we were able to add, we got our total. All right, let's move down to Charlotte. I want to move this so you can see the whole question. All right, how should Charlotte rewrite the fraction to add? What steps could Charlotte follow to add the mixed numbers? What different ways could Charlotte use to calculate the total? They forgot the 2 in there. Okay, so Charlotte, she just broke down the mixed numbers and added the different parts. She added the whole numbers, and then she added the fractions and then combined them right here. All right, so how would you check the total in Hugo's method is equivalent to the total in Charlotte's method? So equivalent, that's a good word. Equivalent means equal or the same. So what it's asking is, how do we see if the total here is the same here? Because this is an improper fraction. And just looking at these two, it's kind of hard to tell if they would be equivalent. So a really great way to do this would be, we could take the improper fraction and make it into a mixed number to see if it matched Charlotte's. Or we could take Charlotte's and change hers into a mixed number to see if it matched Hugo's. So for example, I'm going to use Charlotte's. You could use Hugo's if you want, but I'm going to use Charlotte's. So 2 and 11/12. Remember, it's going to be 12 times 2, which is 24. And then 24 plus 11 is 35. So it would be 35, and then our denominator 12. And now look, that matches Hugo's answer. So that's the right answer. So these are equivalent or the same. So let's move on to the next part. Now on these numbers here, I'm not going to go into in-depth as much because we covered these, went over them really well in 6.4 and 6.5. So I'll get you started on each of them, kind of show you what you're going to do. But I have total confidence that you guys will be able to do this on your own. Alrighty, so the first part. Estimate, then calculate each total using improper fractions and show your thinking. So we're going to be estimating first, then we're going to be calculating, and we're going to be doing improper fractions. So not mixed numbers, we're going to be doing improper fractions, which means we're going to change these into improper fractions. But first, we're going to estimate. And I want you guys to make sure to put your estimate here, or make sure to write it somewhere. And if you're printing these out, right, be sure to write your estimate here. If you're using Canvas and you're just entering the numbers online, I'd like you to put a little box, a text box here, and put what your estimate is. Now remember, when we're estimating, that means we're just getting an about answer. I think it's about this much. So if we were using cups up here and we were estimating how many cups, we'd say, oh, I think it's about this many cups. You're looking for an exact answer. Alrighty, we're just going to be thinking and using our critical thinking to figure this out. So let's think about this logically. So we're going to use our fraction strips again. We're going to be using fourths and thirds. Oop, there we go. Fourths and thirds. All right. So our whole numbers show that we've got 1 plus 2. So 1 plus 2 is 3. Okay. And then we've got 1/4 and 1/3 that we would add together. Now, if we look at these, if we put them side by side, it shows me that if we add 1/4 plus 1/3, it's going to be just a little bit over a half, because where this one is the halfway point. So this would be half. So it shows me that 1/4 plus 1/3 is just a little over a half. So I think that my estimate is going to be 3 1/2. So whenever you're estimating and you're using fractions, I want you to make sure that you think about how many of these are in a whole. Oh, I'm sorry, that one's upside down. Oh, and you can't see these. Hang on. Sorry, guys. There's your fourths. There's the thirds. Okay, so whenever you're looking at fractions or you're estimating fractions, I want you to think about them this way. Think about how many fourths are in a whole. There's 4. And that way you're able to visualize it and get a better idea of what you're estimating or what you're adding together. All right, so let's go ahead and get started on this one. We're going to solve this and figure out the exact answer. We'll see if we're any close. Oh, and to see if we're close, I'm going to go ahead and change this into improper. So 2 times 3 is 6. 6 plus 1 is 7. So 7/6. All right, that's my improper fraction. So let's change these into improper. So 4 times 1 is 4. 4 plus 1 is 5. So 5/4 plus 3 times 2 is 6. 6 plus 1 is 7. So 7/3. Okay. And remember, when we have unrelated denominators, we're going to change them both. So let's just multiply them together. So you're going to be using 4 times 3. Okay. So your answer is going to end up being 12. All right. Now I'm gonna stop here because I know that you guys will be able to figure out that you need to change these into the common denominators before we can get to 12. And over here, it's not going to be 12. It's going to be a different number because we're going to multiply these. All right. So I'm going to leave it there. I'm going to let you guys do that on your own. And then, let's go ahead and go to the second page. Miss Stafford is having some issues. Hang on just a second, guys. Goodness gracious. Okay. So calculate each total using mixed numbers and show your thinking. So look, we're going to be using mixed numbers, which means that we could break these down and be able to solve them that way, but we're still going to need to use these two. We're going to have to change those into common denominators, and since they're unrelated, since 4 can't go into 5 evenly and 5 can't go into 4 evenly, we're going to be multiplying them together to get our common denominator. And we're going to do the same thing here too. All right, so I'm going to leave you guys to do that because we've done that on the last 2 assignments, and I think you guys have got it down. This is just some more practice. All right, use a method of your choice to calculate each total and show your thinking. So, or you're going to use the method you want to do. So you can either add them together with the mixed numbers here. You could have it be a mixed number at the end, or if you wanted to do it this way and change them into improper fractions first, you can do that too. It is totally up to you guys. All right, so you're going to do these two together. Remember, you need to change the denominators to be the same. And then down here, I'm going to go ahead and get you guys started on this one. Calculate the total number of hours that were worked, then write the answer as a mixed number. So our answer down here is going to be a mixed number. So what we're going to do is we're going to add Kathy's timesheets all together because they want to know the total number of hours. And remember, when we see total, what does that mean? That means we're going to add. Okay, so that gives you a hint on what you're going to do for your word problem. So let's go ahead and look at this. So we've got Monday, which is 1 1/4 hours, plus Tuesday, 3 1/2, plus Wednesday, which was 2, plus Thursday, which, oh, she didn't work on Thursday. That was her day off. And then Friday, 2 1/3 hours. So I'm going to add all of these together to get a mixed number. Now, what do we do with mixed numbers? If we want to end up with a mixed number, we're going to simplify it. We're going to break it down. So I'm going to take all my whole numbers out first. I'm going to take my 1 plus 3 plus 2. I don't really need to put plus 0 because it doesn't really count. So plus 2. So those are my whole numbers. Now for my fractions, 1/4 plus 1/2 plus 1/3. Okay. So let's focus on our fractions first. We're going to have to change all 3 of these into a different denominator because we have to add them together. So we're not going to do 4 times 2 times 3 because we need one number that all 3 of them can go into, but we don't need to multiply all of them together. So let's see, could I do 4 times 2, 8? Oh, well, 3 doesn't go into 8 evenly, so 8 can't work. What about 2 times 3? That's 6. Oh, but you know what? 4 can't go into 6. What about 4 times 3, which is 12? Well, 2 can go into 12 because it's an even number. So 12 is going to be my common denominator. So you're going to convert or change 1/4 into something with 12ths, 1/2 into something 12ths, and then 1/3 into something 12ths. Then you can add the fractions together, add your whole numbers together, and then write a mixed number over here, okay? So I think you guys can do this on your own. Go ahead and get started on that. If you have any questions or if you have any issues, you can either rewatch 6.4 and 6.5 because that can give you a little bit of an idea of what you need to do. If you have any questions, please let me know. You can either message Miss Karleskint and she can help you, or you can wait till we meet on Google Meet and I can help you then. But anyway, good luck and you guys have a great day. Bye.